So you've all seen it, more than likely. It would have been an advert for healthcare perhaps, or another stage segment on the news. Research scientists looking off into the middle distance, looking busy in some sort of lab, with clean, crisp white coats, staring off to the middle distance, thinking about the future and some sort of innovation, some sort of a wonderful invention or discovery. Thing is, not all chemists wear white coats. So it's a bit of a strange saying, but it's a common slogan, and it gets you thinking, like, how could that be? Like, don't you need to be in a lab to do chemistry? Don't you need to be working with Bunsen burner, mixing some chemicals, heating them up so they froth or steam? Well, if you're like me, and as I said, like when I was 16, I saw that slogan on a poster in a chemistry lab at school. And I was thinking, well, could that be me? I mean, this was meant to be an inspiring poster. And that was like, over 20 years ago. Now, since those days in the lab, I've qualified with a PhD in chemistry, but I'm also a PhD in theoretical chemistry. And I don't wear a white coat anymore. A great deal of chemistry is being done by people that don't wear white coats. So the road to where I am now, as still a chemist of sorts, is a bit of a wiggly one, and it's born out of my love of chemistry, physics, maths. And if you had to have asked me when I was 14, 15, 16, like, would you be a chemist in the future? Can you imagine yourself as a chemist? Could you imagine yourself writing for a science magazine? I would have laughed at you. I didn't think myself a programmer like some of the other really computer science kind of nerds. I would say nerds, I'm a nerd. But the point is, I didn't consider myself like them. I didn't consider myself much of a writer compared to others in my class at high school who were good at writing, spelling, grammar, and so forth. Now, I actually thought I was going to be an archaeologist. I thought I was going to do history and carry on with that. Maybe use some chemistry, maybe, for like, carbon dating and so forth. I thought maybe I would have ended up writing games for a certain company that makes plastic toy soldiers. But really, being a computational chemist was born out of the fact that I frankly suck at practical chemistry. I still went on to do chemistry, because I took chemistry at A level with maths and physics, because from that you could get really into any career such as archaeology. Now, chemistry, I was pretty bad in the lab, even as an undergraduate, in the sense that I could make most things, but generally you were meant to get nice pristine white powders that come out at the end of your synthesis, and a lot of time my stuff would turn out as brown muck. Wasn't very appealing, wasn't the idealized thing that you would create. Now, the thing with chemistry is that underpinning it all are the laws of nature, physics, maths, electrons allowing atoms to bond to each other. They follow strict rules. Chemistry follows strict rules when you're not crap at doing synthesis. So I started to get more into the computing side, the more theoretical side of how chemistry operates. Now, I wasn't totally against computers. Like I said, I didn't consider myself a programmer initially when at high school, but I still had a passion for computers. And that comes from the fact that when I and my sister one Christmas got the peak of computing at the time, an Amiga 500. So you could play games, but it wasn't a SNES and it wasn't a Mega Drive. You could program games on it as well. So we would get books from the library, and you could program up in BASIC, the computer language, some rather rudimentary computer games that had simple characters moving around, made up of alphanumeric symbols, but it was still a computer game. You had to tweak the programs a little bit because they were designed maybe for one computer and not for the other, because BASIC was slightly different on an Atari compared to an Amiga. And then, at high school I was doing other things. like that. So for our IT classes, we'd be doing a bit of programming through controlling a computer-aided design turtle. It's called a turtle, but on screen it draws shapes. And you give it a set of instructions on how to draw those shapes. So those IT classes and those rainy Sundays programming were not wasted and prepared me for what I would be doing now. So how do I go then and take all of that and go from being a chemistry student, undergraduate, to being a theoretical chemist and then on to being a programmer? So as I said, I had more of an aptitude for the mathematics side of things, for the quantum mechanics lectures and exams. And so I took a final year project, which meant it was in the computational chemistry lab, and I was performing modifications to a program that was running Fortran. I was submitting simulations to a server, so a HPC server, a high performance computing server that ran on Linux. I was doing all of that. I wasn't actually in the lab like the rest of my year group at university who were doing synthesis, but I was still a chemist. That's fascinating, really, because we can learn so much about chemistry, so much about reality, about materials from doing simulations. So I finished my undergraduate. I then continued to do a PhD in the same group. And not only was I doing more simulations of water, the most ubiquitous and fundamental chemical there is, but I was also I was doing those simulations using neural nets, using machine learning. So we were using them to interrogate reality, to understand better how atoms interact with each other. And all of that training, all of that work still stays with me. So, and carried on through my career into where I am now. But it's not an easy career becoming a postdoc, because if you want to, you can join other groups, you're doing research, but you're chasing papers, publications to make that next step up so you can get the funding to set up your own research group. And if you do a lot of programming, or at least I found, if you do a lot of programming, you're into that kind of science, you don't have the incremental outputs because you're developing large pieces of software to do some work. And that's a hindrance, that's a roadblock. So what I didn't realise was that while I was doing all these postdocs, there was a career path being developed called research software engineers. And that's what I applied for when I moved to the University of Nottingham. There, I took on this role, and this role is about providing software programming support for other researchers, because researchers of all colours, of all kinds, any type of research they do, generally have a lot of data, or they've got some tasks they need to do a lot of times and they need to have it reproducible. And the hindrance to making this research easier is software. Software's infrastructure, it's all around us. It's not something you just create for the single paper and then forget about. It's something you use over and over again. That's kind of what I was doing. And in this new role, because now research software engineers are commonplace, or becoming more commonplace, I was able to learn new programming languages, new techniques, and new methods, and support researchers outside of my niche of computational chemistry and outside of even simulating water. So now I'm able to help many different areas of science, engineering, medicine. The role is rewarding because I get to look at and think about different types of research, different types of projects, and I'm valued for the fundamental support that I give to these researchers and the fact that I can allow an interface between their work and computers, because I can cut through that jargon and go, oh, you want to do that type of chemistry, but you want to do this kind of software design. I may not be that software designer per se, but I can recognize within our group the software designers that can support them, or the data analysts even. And that's led to me now leading software development projects. I supervise other research software engineers, provide that support, provide that niche chemistry understanding that I have within the group. And then today, I continue as this research software engineer with this background of chemistry, with this background of material science, of this background of machine learning, in a role that never existed when I started even thinking about A-levels. It didn't even exist when I applied to do a degree. I don't think it was even there when I started my PhD. And so it certainly wasn't there when I looked at that poster in the lab saying, not all chemists wear white coats. So that's where I am now. And off the back of that, I write for a science magazine, and I still dabble and write games even. That career pathway that I thought I wouldn't get into. So that's me in a nutshell. That's, the type of researcher I am.